Hello friends, let's welcome to the another episode of Let's Decode C ECG series. And today we are having this ECG which shows these very striking bizarre shaped broad QRS complexes which are not preceded by P waves. So these are called as PVCs, that is premature ventricular complexes. And if you look at carefully, the pattern of VPCs are the every second beat is your VPC. So this is normal sinus impulse, this is VPC impulse, normal sinus impulse, VPC impulse. So every other beat is your VPCs or PVCs, premature ventricular complexes. So it is ventricular bigeminy. So when every other beat is PVC, it is called as ventricular bigeminy. So this ECG is showing ventricular bigeminy. Ventricular bigeminy. If there is PVC coming after two normal sinus impulses, it is called as ventricular trigeminy. Or if every third beat is VPC, it is called as ventricular trigeminy. If every fourth beat is VPC, it is called as ventricular quadrigeminy. So first, how did I say it is PVC? So what are the diagnostic things to call it as PVC? So first one is it has to be broad QRS complex, that is more than 120 milliseconds QRS, and it should not be preceded by P waves, and ST and T wave changes are opposite to that of QRS. So these are the three criteria to call it as PVC. So here you see these are PVCs, these are your PVCs. So there is no P wave, and these QRSs are wide, more than 3 boxes, and these ST T wave changes, ST depression and T wave inversion, these are opposite to the direction of QRS. See, in this QRS is downwards, but ST T wave changes are upwards, opposite to that QRS. So these are PVC. Every second beat is PVC, so it's called ventricular bigeminy. Now we have to know where is the focus that is generating this PVC. PVC is nothing but here. Let's suppose this is your ventricle. I will draw in the next page. Let's suppose these are your ventricles. Okay, there may be focus here which is generating the electricity and causing the appearance of PVC. So how to localize which side the foci is, whether it is on the right side or left side or apex or lower side. So for that you have to see lead V1. In lead V1, if it is QRS complexes of PVC are predominantly downward, it is suggestive of right-sided PVC, right-sided focus. Sorry, right-sided foci is there. That means it has left bundle branch block pattern. So right-sided. Now we have to know whether it is on the apex side or the outflow side or inflow side. So for that you have to see the axis. So in lead 1 it is upright, in lead AVF it is down, predominantly down. So both are leaving each other, so it is left axis deviation. When there is right sided foci with left axis deviation, it is seen in apex. So here the foci that is generating the ventricular premature complexes is present in the right ventricular apex. If I want to make you understand with the pictorial diagram, let's suppose these are your ventricles. So left, this is left ventricle, this is the right ventricle. So this is the apex of the left ventricle. So our right ventricular apex is here. So here is the foci which is generating the PVC in the given ECG. So now you got the point how to localize the PVC foci. So first we have to see V1, where in this case it is predominantly downward. So downward means right side, upward means left side, downward means right side. Why? I will tell you here, I will explain here. Let's suppose these are your ventricles. Let's suppose foci is here, right side. This is right side, this is left side. Whenever there is focus, this generates electricity in this directions. So is V1 is here, V6 is here. So this current goes in this direction. So it is going away from the V1. So when current goes away from the V1, one basic thing I want you to remember is whenever the current goes away from the electrode, it is perceived as negative. Whenever the current goes towards the lead, it is perceived as positive. So in V1, if the predominant QRS complex is predominantly downward, that is deep S wave, that means it is on the right side, the focus is on the right side. Let's suppose what happens when the focus is on the left side. Let's say this is right ventricle, left ventricle. Let's suppose focus is here, this is V1. So this current is going away from the V6 towards the V1. So when current goes towards the electrode, it is perceived as positive. So left sided focus will cause positive deflection in V1 and right sided focus will cause negative deflection in V1. So this is how you have to identify whether it is on the right side or left side. After identifying whether it is on right side or left side, now here in this case it is on the right side, predominantly downward. So after that you have to see axis. See PVC axis you have to see. In this predominantly upward, lead one predominantly upward, lead AVF predominantly downward. That means left axis deviation. Both are leaving each other, left axis deviation. So right sided foci with left axis deviation means the lesion or the foci is present in the apex. So this is ventricle bigeminy with foci in RV apex. Thank you. Hope you understood the point and this video is helpful for you. Thank you.